Hey, this is Mr. Mola for lesson 2-5, solving compound inequalities. All right, so a couple things we'll talk about first. So the word compound, just like in English, a compound word means two words that you put together to get to be one, like goldfish. Gold is a word by itself. Fish is a word by itself. Goldfish together is a word. Race car. Race is a word by itself. Car is a word by itself. You put them together, you get race car. So it's kind of the same thing here. You have two inequalities that we're either going to put together or we're going to pull apart one giant inequality into two smaller inequalities. And there's two kind of inequalities that we have. We have and problems and we have or problems. And so kind of think about the difference again in English, what those words mean. If your parents say clean your room and do the dishes, well, that means you're doing two things. You're cleaning your room and you're doing the dishes. If they say clean your room or do the dishes, well, then it's like you have a choice. Are you going to clean your room or are you going to do the dishes? And they look pretty different in math here. Everything right here in exploration 1 is an and problem. Okay, so I need this number to be greater than or equal to -6, and I also need it to be less than 3. So not a lot of options there. It could be, for just talking about whole numbers, it could be -6 or -5 or -4 or -3 or -2 or -1 or 0 or 1 or 2. There's lots of numbers that it can't be and only a small select numbers that it can be. So the way that we write and problems, so we're going to put our x in the middle, okay, and we're just going to write down the two things that are happening. So there's a 3 on that side and a -6 on this side, okay? So I need x, it's going to the right, so I need x to be larger, so greater than -6. It's a filled in circle, so equal to. So kind of backwards because I said greater than, but I drew a less than sign because my x is backwards, okay? So x has to be greater than or equal to -6. Here, for my 3, I'm shading to the left. Those are less than signs, so x needs to be less than 3. So if it kind of helps to like cover it up or do it one by one, that would help too. So if I'm writing these out separately, so x needs to be greater than -6, x needs to be less than 3. So I kind of put those two together and got that. So I took two single words, put them together for a compound word. I took two single inequalities, put them together for a compound inequality. And we got to pay attention to the sign as well, because one had an equal to sign and one did not. Okay, same thing here. I got a -5 and a +4, and I'm going to write these out over here first. So I need x to be greater than -5, and I also need x to be less than or equal to 4. So we got to figure out how we're going to write that as one compound inequality. So x is less than or equal to 4, but x also needs to be greater than 5. Again, it looks like I wrote a less than sign. You're right, but since the x is second, x is greater than -5. Okay, here we'll see both dots are closed. So I have a -4 and a 5 here. Same thing. So I need x to be greater than or equal to -4. So like -3, -2, -1. And then over there, I need x to be less than or equal to 5. So my signs are going to look like that. X is greater than or equal to -4, but x is also less than or equal to 5. Same thing here. We got a -3 and a +6. So x needs to be less than 6, and x also needs to be greater than -3. Two open circles, so no equal to signs there. So these are what we call and problems. And problems always go towards each other. And problems are always written like this as a compound inequality. Other kind of problems we have are or problems. And these are a little simpler. You'll see or problems go the opposite way. They're not going towards each other anymore. One's going to the left, one's going to the right. And these give us a lot more options. My x can be less than -6. Well, after -6, there's a billion numbers, infinity amount of numbers that are less than -6. X needs to be greater than 3. Again, there's a billion numbers that are greater than 3. Really, x just can't be -5 or -4 or -3 or -2 or -1 or 0 or 1, 2, or 3, any other number fits perfectly fine. And these are a little easier to even write then because I'm going to write it out as two separate ones. So I want x has to be less than or equal to -6, or x has to be greater than 3. So even writing out or problems makes it a little easier because I don't have to worry about which way the sign's going and it's not going to be backwards. Okay, same thing here. I need x to be less than -5, or I need x to be greater than or equal to, because it's a filled in circle, 4. Did I write my or? Okay, here I need x to be less than or equal to -4. Here I need x to be greater than or equal to +5. So two filled in circles, so two equal to signs there. Here I got two empty circles, so no equal to signs, so x needs to be less than -3, and x also needs to be greater than 6. And these are both or problems. So there's kind of an intro to our two kind of problems. And now let's kind of look at see what they look like when we have to write them out. Okay, so a number u is less than 7 and greater than 3. So I got u in the middle, and u has to be less than 7, but it also has to be greater than 3. And we have that and. So a big hint for us here is that my graph's going to be going towards each other. I'm going to put 3 here. That would make that 4, 5, 6, 7. I'll put 7 here, two open circles because it's just a less than and a greater than, and it's only going to be in the middle. So really, u can be 4, or it could be 5, or it could be 6, or all those decimals in between, but it can't be anything else. Okay, a number d is less than -2, or, so we like these, greater than or equal to +2. So again, when I'm graphing these, I know these and problems are going to go towards each other, and these and problems are going to go away from each other. So I'm going to put -2 over here, put an open circle, and we're going to the left here for that one. There's -1, there's 0, there's 1. This would be 2. Filled in circle because it's equal to. And I'm going to the right. So anything greater than 2. All right. Let's look at a couple more here. So number 3, a number is no less than 2.4. So S is no less than 2.4. So that really means it has to be bigger than -2.4 and fewer than 4.2. Okay, so I have -2.4. This one's not going to be a nice graph because they give us decimals. So I got -2.4 filled in circle, and I'm going to the right. And we'll just say 4.2 is over here. And I got an empty circle, and we're going to the left because it's less than. So really, S can only be one of these numbers in between. All right, let's look at one more. That's an or problem here. So we got 2 and 2 done. A number C is more than -4, or it is at most -6.5. So that means it's not going to get past -6.5. So let's do -4 over here. Open circle, so it needs to be greater than -4. So going this way, like -3, -2, -1. Or it could be less than or equal to -6.5. So anything going to the left that way, like -7, 7.5, all those ones. Okay, so these are just written out. We didn't really have to do any math there. Just kind of had to worry about our sign. Then we got some where we're going to have to worry about our math. Again, and problems are going to be a little more difficult than the or problems. So here, when I have an and problem, and I can tell it's an and problem because if we fast forward to number 8, it says or. So if it doesn't say or, it's an and problem. Here what we do, math, you know, we're all friendly and equal. We're going to share. So we are going to share that middle equation. So I'm going to write two equations. I'm going to split my compound inequality just like we can split a compound word. And I'm going to split this into 2. And we're going to share that middle. So we're both going to share an x minus 3. And then we're going to take the signs from both the left side and the right side and kind of write it out. So if you kind of see, 4 is less than x minus 3. And then I wrote x minus 3 is less than or equal to 7. So we both shared the x minus 3. And then we took the left side and took the right side. So here then we just solve like normal. So add 3 to each side, add 3 to each side. I get 7 is less than x, or x is greater than 7. And same thing here, add 3, add 3. I get x is less than or equal to 10. Okay, same thing, this is an AND problem. So I know if I do this right, I should have both of them facing the same way. So x is greater than 7, so that number is like 8 and 9. So I'm going to go that way. Here, I have x is less than or equal to 10, so I'm going to fill in my circle for the equal to, and that's numbers like 9 and 8 and 7. So we know we did it right. Our graph is going the same way, so then we're good there. Okay, let's look at one more where we have to share the middle. So 15 is greater than or equal to negative 5g. So we're both sharing that negative 5g. On the other side, negative 5g is greater than or equal to negative 10. So we're both going to share that middle. So I'm going to divide both sides by negative 5. So I end up with negative 3. And since I divided by a negative, I'm going to flip that sign over. Is less than or equal to g. Same thing here. I'm going to divide by negative 5. And so I end up with g, again flipping the sign because I divided by a negative, is less than or equal to 2. And same thing, since I have an AND problem here, I know they should be going towards each other. So g has to be greater than negative 3. So a number like negative 2, negative 1, 0. And here, negative 2, negative 1, 0, 1, 2. I'm going to put my 2 here with a filled in circle, and g has to be less than 2. So like 1, 0, negative 1. So then the only thing they have there is the middle. Okay, so those are the AND problems. OR problems are a little simpler because they already split it up for us. So we like these. So I don't have to worry about splitting up. I'm just going to solve both problems. So it's a plus 4, so I'm going to minus 4. So I get z is less than negative 2. Over here, it's negative 3 times z. So I'm going to divide by negative 3. So z, and then I'm going to flip my sign since I divided by a negative, is greater than, not less than anymore, 9. So I need a number that's less than negative 2. So open circle going to the left, and greater than 9. So an open circle, and now greater than 9 goes to the right. And you'll see we did that correct because they're going in opposite directions now, because now it is an OR problem. All right, let's look at one more OR problem. So here I'm going to subtract 6 from each side. So I got 2t is less than or equal to 4. Divide by 2, divide by 2. So t is less than 2. Then here I'm going to subtract 7 from each side. So I got negative t is less than or equal to negative 5. And I got to get rid of that negative 1 in front of the t. So I get t is greater than or equal to positive 5. So I got t is less than 2, so an open circle at 2. Numbers less than 2 go to the left. And then I got numbers greater than or equal to 5, so 3, 4, 5. So fill in that circle. Numbers greater than 5 go to the right, like 6, 7, 8. So again, an OR problem. They're going in opposite ways. So always a good way to double check your work. These are AND problems. They go towards each other on the graph. They're shading in the middle. These are OR problems. They say OR. And when I shade them on a graph, they go away from each other.